Guys, I'm guessing this is going to be my last video that I make for the school year this year. This is a little video on independent versus dependent probability, which was the third problem set that you guys were doing. I had a couple people message me saying they're struggling with it. So here's a couple questions I'm going to look at to kind of talk about what it means to be independent, or what they say not dependent, and this specific question versus that would be dependent here. So I'm going to give a little bit of vocabulary and a little bit of thought process on it. So if you look at this question here, this question says, suppose a student rolls a pair of fair six-sided dice. Let A be the event that the first dice lands on 2, and the second dice, B is the second dice lands on 2. So what's the probability that the first dice lands on 2? Well, we haven't even taken into consideration the second dice yet, so this is just a 1 out of 6. And the probability the second dice lands on 2 is still a 1 out of 6. Now, what you're realizing here, excuse me for my yawning, is that if I have a first dice in my left hand and a second dice in my right hand, and what I do with those two dice does not affect the other one necessarily. This is asking me, I want to know what's the probability of me having my first die land on 2 and my second die land on 2. When you take those two things together, hopefully if you watch the videos, you're realizing you have two different events going on, and you're going to, the likelihood of both of those things happening is obviously less. It's like getting snake eyes when you roll die. If you get snake eyes is when you both get a 1 on both die, and, the likelihood of that happening is pretty low. Less than 1 out of 6. So this says what's the probability that the first die lands on 2 and the second die lands on 2. I'm going to take my two chances, and I'm going to multiply those guys together. So 1 out of 6 times 1 out of 6 is just 1 out of 36. And then this question here says, are they independent? Yes, clearly they're independent. What I do with my left hand does not affect what I do with my right hand. So that's one type. Now, this is a little bit of a different way of looking at it. And I'm going to draw a Venn diagram again in this, as I did in previous lessons. So there are 300 students in the 12th grade high school class. 120 of these students have at least one sister. So I'm going to do my Venn diagram here. If you were in my Google Meet a little while back, we discussed this. So and then I have some students down here that I'm going to take into consideration. These people I'm going to talk about, they have at least one sister. I'm going to call this the sister group. And these students here, they have at least one brother. I'm going to call that the brother group. Now, these people in the middle, obviously they have a sister and a brother, at least a sister and at least a brother. And then these people here, they are only children, they don't have either. So I'm going to fill some circles in here. All 4 of these spots, 1 spot, 2 spots, 3 spots, and 4 spots must sum together to be 300 students, because everyone falls in one of these categories. So it says 120 students have at least one sister. So this circle right here is going to have a total of 120 in that entire circle, and 100 have at least one brother. So this circle here is going to have at least 100 in it. And out of the students that have at least one brother, 40 of those have at least one sister. So this guy right here is 40. Now this whole circle over here on the right, the brother circle adds up to 100, and we just used 40 of those students. So these 60 don't have a sister. And then this circle over here, I'm going to highlight him in green for a second. I should say her, because it's a sister group. So I have 120. I take out 40. And this is 80 people who just have at least one sister, but not at least one brother. So then I'm going to come down here to this group just for kicks, because I might need it later. I'm going to add up my numbers. I know they need to sum together to be 300. I have an 80. I have a 40. That's 120. Plus 60 more, that's 180. So down here, I have 120 students who don't have a sister or a brother. So what is the probability of me picking someone out that has a sister? Well, there were 120 students that had a sister, and then we had 300. We don't need those silly calculators. We can reduce this down to 12 out of 30, not 300. And then 12 out of 30 reduces down. They both divide by 6, so that is a 2 out of 5. That's about a 40% chance you're going to pick somebody out that has at least one sister. Now I'm going to switch gears to at least one brother. There were 100 people who had at least one brother out of my 300. Again, we don't need a silly old calculator. Use our brains here. Those both divide by 5. That is 2 out of 6, which comes down to 1/3. So there's a 1/3 chance, 33% chance we find someone that has at least one brother. Now this guy right here says probability of A and B. So you had to fall into this gold area right here, which was 40 out of my 300 people. And that comes down to 4 out of 30, which they both divide by 2, which is a 2 out of 15 chance that I pick someone that has at least a sister and a brother. Now hopefully you watched some videos understanding that this vertical bar means given. Given means probability that you have a sister, given the fact that we know you have a brother. So in this case, we are only going to look at the B group. The B group is the brother group. And in the brother group, we had 100 people. So I'm only looking at the B group. I've placed in class I would have discussed, we place a condition on the people. We're not looking at all 300. We're only looking at the people in my condition, which is 100 people because they had at least one brother. So I'm looking at this group right here, which is all my people who have at least one brother. And of those people, what group falls in A? So that is a 40 out of 100 in this case, which still comes down to 2 out of 5. Now, look what has happened in this case. I'm going to change some colors here so we can make it stand out. We're going to call it this purple. So the probability of me having a sister is a 40% chance. And the probability of me having a sister, given the fact that I already know I had a brother, is a 40% chance. And so what's going on here is it doesn't really matter if I had a sister or not. I still had a 40% chance. I'm sorry, it doesn't really matter if I had a brother or not. I still had a 40% chance of having a sister. So these things are independent of each other because it does not matter. Your probability did not change. If this value would have changed, if you placed this condition, this letter B, if you placed this condition on the group and it changed the likelihood of what was happening, then they would have been dependent. One thing would have depended on the other. But since they didn't, they are independent events. I think that is my best way of explaining what's going on here. I hope that helps a little bit. And let me know if it doesn't. Shoot me a message. Hope you guys are doing well. Miss you like crazy.